What's up, everyone? If you've been following me on LinkedIn, you've probably seen my series, VXLAN Fabrics, Complex or Misunderstood. And in that series, I've walked through physical topology, underlay configurations, BGP setup, and overlay config. And today, I'm going to bring all of that series together and show you in a lab how we build out a VXLAN Fabric. Now, in this VXLAN Fabric, we're only doing L2VNIs, and I'm providing external connectivity between the different hosts inside the fabric using a router with router on a stick configured and just different default gateways. That external router also provides internet connectivity and access to two external hosts. So what we're going to show you here is, how the underlay works. We're going to look at the different routing protocols set up there. We're going to look at multicast. And then we're going to walk through the BGP configuration and how all of these different hosts are talking to each other. And then we're going to look at each of the servers and how packets traverse the fabric to both reach out to the internet and between each other, when they're on different VTEPs in the fabric. The physical topology is really the setup of how we want to deploy our VXLAN Fabric. And if you followed my series since day one, when I talked about it, I said that it's basically a fully customizable chassis that you can do whatever you want with and put whatever kind of devices you want in there. And why did I say that? Well, if we think about these spines here as a fabric module, in a chassis, a fabric module provides the bandwidth between the different line cards, your interfaces, in a chassis. Well, we have these two spines here, so we could consider those as two fabric modules that are connecting these three leaves down here. And the leaves basically are our line cards. Now, in this configuration, I only have virtual devices, but let's pretend these were physical. I can have these two spines today providing my bandwidth between the different leaves. And these leaves, maybe this one is a 100 gig switch, this one is maybe a 1025 gig switch, and maybe this guy is just another 1025 gig switch. It's super customizable. This could be fiber, this could be copper, this could all be 100 gig. It really depends on what you need for your deployment. But the really cool thing is, we've got these two spines today, we've got these three leaves. What if I want to expand? What if, I don't need more leaves, but I need more bandwidth? Well, I can add another set of spines. We could go from 2 to 4, and I double my bandwidth. So if these are 100 gig links, I've got 200 gig of bandwidth. I could up this to 2 more spines, and now I've got 400 gig of bandwidth. So just by adding spines, just by adding 2 additional uplinks, I doubled my bandwidth in the fabric between all my devices. So that's what's really nice about it. Like I said, it's like that chassis. We've got the different fabric modules, but the real difference here is that at some point you can't add line cards to a chassis. You can't get more bandwidth out of it. And with the VXLAN Fabric, there will be obviously a point where you got to consider oversubscription of the spines, but you could expand out the spines to say 8, and you're getting 800 gig of bandwidth here potentially throughout the fabric, and that's a lot of speed for most networks. So when we start thinking about that, there's a lot of flexibility that, today you might want to start small. Down the road, you grow it out as your needs increase. We're going to talk about building the underlay now. And in the underlay, there's a couple things we need to do. The first is we need to get interfaces assigned with IP addresses. Now, there's a couple ways to do it. I'm going to show you a really easy method, and I'm going to show you the configuration for that, and it's called IP unnumbered. I have a doc up here that I'll share that kind of explains what IP unnumbered is doing, but basically we're going to set an address up on the loop back. We're going to put the layer 3 interfaces into a point-to-point configuration and set them up for IP unnumbered, and basically that allows us to only use the loopback address as our IP address for the interfaces. The next thing we're going to talk about is multicast. Now, I'm not going to get into a whole big thing on multicast here, but there's a couple things you might want to research, and the first is Anycast RP. And the Anycast RP is basically a point for our VTEPs to register for multicast for the VNIs that they want to listen to. And basically, with the Anycast RP, both of the spines are acting as RPs. You get some redundancy in this configuration. You get a hot spare. And then the last part of multicast is that all of these interfaces are configured in sparse mode. So basically, if you want to understand a little bit better what sparse mode's doing, in this case it's saying that only segments with active receivers that explicitly want the data will receive the traffic. If you want to understand better like what all the multicast configuration is, I would highly encourage you to go read the documents, which I will share in the video. So let's go ahead and get our network set up. So let's look at the first spine here, and I'm going to show you the running config one here, and I'm just going to come over here and do show run. And we can see that we've got a couple features turned on, but the two that I'm most interested in are PIM and ISIS. Now, I have OSPF turned on as well. Either underlay routing protocol will work just fine, doesn't really matter. I started this lab out with OSPF, and then I moved it over to ISIS because that's my preferred routing protocol. PIM is turned on so that we can provide multicast connectivity for our BUM traffic, which is broadcast, unknown unicast, and multicast traffic for our VXLAN Fabric. The other stuff that's here, that is all specifically related to the overlay, and I'm going to skip that for now. We'll come back in just a few minutes. We're going to move on to the next set of configuration, and we've got this PIM RP address set up. Well, this is the rendezvous point that we're going to use for multicast, and I've got it set up as 1.1.1.1. We'll see where that's configured in just a minute, but it's on one of the loopback interfaces. We've defined our source-specific multicast range, and we've also defined the Anycast RPs that are part of this environment. This is spine 1, this is spine 2. You'll note that they are both using the same IP address. That is by design. That is how we get the fault tolerance and availability for the RPs. Next, we're going to come down here, we're going to look at the Ethernet interfaces, and like I had mentioned, we're using IP unnumbered, and it's really simple. We take these switch ports, we turn them into layer 3 interfaces with no switch port. I'm using jumbo frames, so I have MTU 9216 set up. The interfaces are set up as point-to-point, which is a requirement to configure the IP unnumbered feature, and once that is set up, you could do IP unnumbered loopback 0. I use loopback 0 as my the interface I want my IP address to come from. Those interfaces are set up with ISIS for routing, and they are set up with PIM sparse mode. We'll come down. There's a lot of interfaces that are not in use. The next thing we can see is our loopback interfaces. Again, this is the IP address with loopback 0 that we'll be using on all of the interfaces to provide our underlay routing and our IP unnumbered IP address. This loopback 1 is only on the spines, and this is the RP address that we set up for multicast. We'll come down. We'll ignore the BGP config for now, but we have this router OSPF that was configured. I just didn't remove it to show that I had configured it before. And then I have router ISIS VXLAN underlay. Now that is what's actually running my underlay routing protocol right now. If you've never used ISIS before, there's a couple things here. We have the group, or the area I should say, and that's just like the area that you'd have in OSPF. Like you'd have area 0. This is defining the area for the ISIS config. And then we have this system ID, and that is the unique value that defines this as a separate system from any of the others. What I did to simplify the configuration is, if you look, my system ID is 192.168.10.0210. Well, if we look up here, we can see that it's very similar to the loopback 0 address. And all I did was add a couple trailing zeros where it made sense, or I could guess in this case it was just there's this 100 right here. So we've got 192, 168, 100, 210. The IS type is set for level 1. Again, if you want to know more about ISS, you can read this, but this would be the equivalent of a totally stubby area in OSPF. And then I've turned on address family IPv4 unicast. Now we're going to skip the BGP config, and we're going to go over and just take a look at a leaf and see what the differences are between the configs. So I'm over here on leaf 1. I do a show run. Again, we can see the same features are configured. I've got ISIS and OSPF set up. I have the PIM address set up. Now, you'll notice that the Anycast RP config is not there because these are not participating in that. They are just trying to connect to the RP to get multicast. There is a little bit different configuration here. This is part of the overlay. We're going to skip that for now. The NVE interface, that's what defines our VTEP. Again, that's part of the overlay, and we'll cover that in a minute. But we'll see these Ethernet interfaces, just like the spines, are configured with IP unnumbered, the ISIS routing protocol. And again, this makes this super simple. This configuration basically gets slapped on every single Ethernet interface that's going to connect up to the spine, and if it's a spine connecting down to the leaves, they're all going to use the same IP address. So if you think about when you're scaling out this network, if you've got one address that you can assign to all of your interfaces and just set the interfaces up to use that single address, it makes operating the network much easier. It makes looking at configuration cleaner because you've only got this one address. You don't have like 65 different point-to-point networks showing up in your configuration. It's just this one IP address that answers to all of the other devices. Come down. Again, this configuration is very similar, except in this one we don't have the loopback 1, we just have loopback 0, and that's it. We've got ISIS down here. This is our underlay. So how can I look at the routing protocols? I know people probably are thinking, oh, ISIS is super different. If I do show IP route, I get the routing information just like I would if it was OSPF. And you can see that all of the hosts are listed down here. The paths that I can reach them via. So I've got spine 1 here is reachable via ETH11. Spine 2 is reachable via ETH12. But to get to VTEP2 or Leaf 2, I have these 2 paths I can use. And I also have the border gateway, which is not really operating as a border gateway, just for clarification. It's just what I named it. They both are reachable via ETH1 and ETH2 using the ISIS VXLAN underlay. So how do we verify our multicast configuration? And we're on the Leaf right now. We can do a show IP PIM RP VERF default, and we can see what multicast is doing on the Leaf, and we see that it's pointing to the 1.1.1 address. We see that is reachable via these 2 spine switches here, and that's it. For the Leaf, all we're seeing is the RP that we're connected to. Now, if we go over to the spine and run the same configuration or command, we can see that we get a little more information. We still see the RP information, but we see that we have 2 Anycast RP members, one being spine 1, which is the one we're on right now, and the other being spine 2, which is the 211 host. And that's how we can do a quick validation that we're talking to our RPs, we've got multicast set up properly. We can see that it's up, and we can see the group ranges that we've supplied as part of the configuration. When I did this series, I split up BGP from the underlay and the overlay and made it its own discussion. Now, the configuration for BGP is not super complex. We just need to turn on the BGP feature, and we need to build out our BGP routing configuration. And really, what is the role of BGP here? BGP acts as part of the control plane for the VXLAN Fabric. And there's some things we need to set up so that we can pass some of the layer 2 reachability information throughout the fabric from the leaves to the spines back to the other leaves. And we're going to take a quick look at this BGP configuration. We've got this router BGP 65,000 set up. That's my AS. All of the switches are set up in the same AS. They're all using 65,000. I've turned on the address family IPv4 unicast and address family L2VPN EVPN features. And under this EVPN one, I have retain route target all. That ensures that the routes that are learned in L2VPN from the leaves are passed from the spines to the other leaves within the fabric. So that ensures that we get that layer 2 reachability across the fabric. Now I have this peer that it was an accident that I left it in there, but basically I've created peer templates so that I have this unique configuration, or I guess the similar configuration that's applied across all of my different neighbors. And we see that, again, I'm using AS65000. I'm saying my update source is going to be the loopback 0 interface. My address family for IPv4 unicast. I'm sending the communities, and I'm doing the spines as route reflector clients. That's so that I can pass all my information between the leaves and the spines, even though they're not all connected to each other. And I've done that for both v4 and for L2VPN. And then we can see that I have 3 neighbors set up, and they're all just inheriting that same configuration. So that ensures that, I've got consistency. It provides some ease of management and configuration. And again, I've got these 3 neighbors. I've just got this one command that needs to be applied that sets all of these features and functions across the spine to leaf connection. If we go over and we look at one of the leaves, I can scroll up here, show run. See, we have a very similar configuration. We have a little less information though. For L2VPN, I've set up maximum paths of IBGP to 2 because I have 2 links. I want to ensure ECMP across the links. I have a new template here. This is the configuration to the spines. The AS is the same. The update source is the same. For my address families, I don't have the route reflector configuration set up because these are not going to be route reflectors. These spines will do that for us. And then I have my 2 spine neighbors. But you can see where if I were to add additional spines, I don't have to do a whole separate configuration. Or again, even if I had leaves, it's just a matter of going to each device and saying, I've got a new neighbor, a new leaf, a new spine, and I want to inherit that configuration, and they come up. You get your new leaf configured, you get your new spines configured, and you deploy the configurations to each device and tell the leaves and the spines who the new neighbors are. And it's just with these 2 lines right here. Now that BGP is configured, we can move on to the overlay, and I'm going to start with showing you the features that I have turned on for the overlay. Now, I've already got everything set up across the fabric, but the features that enable the overlay are the VN segment VLAN based, which changes the tagging of 802.1q to use the VNIs. The feature NV overlay actually turns on the VXLAN capability. And then NV overlay is how we turn on the EVPN setup for the fabric. So all of these devices need to have this configuration set up so that they can participate in part of the fabric. Once all that's turned on, one of the unique interfaces that we get on the VTEPs is this interface NVE1, and that's the network virtualized edge configuration. And there's only one of these, and we apply some configuration underneath of it for each of our hosts. Now, one of the things that I mentioned in my write-up was that when you configure the NVE, you don't have to apply your VNIs across every single device in your fabric. So if we look at this one, I have VLAN 101 and VLAN 102 with VN segment 101.01 and 101.02. I have one other VNI, and that's 105.03. If we look at this device, we can see that the only VNIs that are configured here are 101.01 and 101.02, and that's because they are the only VLANs that I have configured here. I don't have a device that's part of 105.03. If we come over and look at leaf 2, and we do show interface NVE1, show run interface NVE1, we can see that we have a slightly different configuration here, and that's 101.01 is set up and 105.03 is set up, but I don't have 102 set up. And that's because, again, there's no VLAN 102 device here. These are the only 2 VNS I have set up, and so that's the only thing that I need to tell the VTEP to participate in. If we look at the border gateway, though, and I do the same show run interface NVE1, we see that I have all 3 in this. That's because this is the switch that provides the external connectivity out to the internet, to my external hosts. And so for all of my VNIs to get out, this is where they need to go, and I need to have all the configurations set up. Now, one other thing you might notice is that I have two different multicast groups set up. I could use the same multicast group for all of the hosts. That is an option. There are some guides that say that this can slowly increase some of the noise on the multicast group. It's really up to you how you want to do it. For a small fabric, you probably don't need a lot. For bigger fabrics, you may want to separate things out. In this case, I have separated out 503 from 101 and 102. And really, it's preference and what you need as far as your system is concerned as you start building it out. But this is how I've got it set up. After that, we'll go back, we'll look at Leaf 1. When we look at the NVE interface, we can see that we're using BGP as our host reachability protocol, and we're using Loopback 0 as our source interface. Now, I've used Loopback 0 for my underlay routing IP. I've used it for this NVE interface. You could, if you wanted to, do a different source interface to separate your VTEP source from your underlay routing source. Some people I know recommend that. I just did it because this is a small lab, but you could set this up, let's just say Loopback 2 across all your leaves and set up your NVE under there. And that's pretty much it. That's all of the configuration we need to get the VXLAN Fabric running. So I've defined my underlay, I've set up PIM, I've set up my ISIS config, we've got BGP running, we've got the NVE interfaces configured, and we've defined our VNIs and VLANs that are on the host. So now let's look at some of the hosts on the network and look at what is happening in the fabric. So let's look at our first host. We've got server A here, and if we go to CML, we can see that it's part of VNI 101.1 with a IP address of 172.101.1.101. And then we can see that server B is also in this same VNI off of Leaf 2 with a IP of 172.101.1.102. And if we come back to our console, we can look at the host and we see we've got Ethernet 0 configured with that IP address. We can also see the MAC address of the host is 75FE. Now, if we were to go back to our Leaf, one of the ways that we can look at the MAC address would be show MAC address table. And we'll see that our 7FE host is coming off of ETH 101 and it's part of VLAN 101. But you don't see in this MAC address table any association to the VNI. If I do a show BGP L2VPN, EVPN, we can see that we have a route distinguisher set up for this VTEP with a L2VNI of 10.101. And one of the first routes that we see here is this 75FE, which is associated with this router that we're on, or switch that we're on right now. From 213, we see a couple other MAC addresses that are part of 101. So let's take a look at this MAC address right here. If I were to guess, if I were to go look at server B, this would be the MAC address that we'd find on the host. So let's go find server B. There's A, here's B. So let's do show IPA. Let's do IPA. And we can see 923A is the MAC address. We'll go back and we see that the MAC address 923A matches what is in this table. So BGP has learned the MAC address table. There are some other things that are occurring here, but this is just what BGP sees. And the MAC address for the reachability is provided in this routing table. So if I come back and we go back to server A, we know the IP address. Let's do a ping 172.101.1.102, and we can see that we're able to ping. If we come over to CML, we can do a packet capture. Now it's going to be one of these two links. Got to log back in. Log back in here. Go look at our lab, and then we'll do packet capture, and we'll do it on both links. So we're going to do a start. All right, and we see the ICMP packet. Now, there's nothing in here indicating that this is happening over VXLAN. We know, because we've got L3 set up on these interfaces, that it has to be using VXLAN. We can come up and we can click on one of these and we get the packet capture. And what do we see? Well, we have two sets of Ethernet packets here, or frames, and we've got one that has VXLAN. Well, how do I know where the actual frame is and where the VXLAN part starts? Well, VXLAN is kind of the breakpoint now in this packet capture that delineates where our encapsulation occurred. And if we look below that, we see Ethernet 2, we see the MAC address of server A reaching out to the MAC address of server B. If we click on IPv4, we see the IP address of server A reaching out to the IP of server B. And we see that it's sent an ICMP. That's the original packet that was sent to the switch before VXLAN encapsulated it. At this point, we're seeing everything above it is the VXLAN portion. And if we look, we see that we've got this VXLAN VNI. It's true. We see the network identifier. We see that it put it into the VXLAN UDP port of 4789. For IPv4, the source destination changes. Now we're seeing the source of VTEP1, leaf 1, to the destination of VTEP2. And then we see the MAC addresses of those related hosts. So this top part gives us what is occurring between the VTEP to VTEP communication with VXLAN encapsulation. This bottom portion shows us the original packet that is the ICMP packet that we sent between the two hosts. So I mentioned that I provided external network connectivity, and so great, we've demonstrated that I've got access between two hosts within VXLAN. How do I look at the external connectivity? How do I validate that I'm actually able to get out to the internet? So I'm going to come over here and I'm going to open up the console. We still have this ping running, so let's stop that. Now let's take a look at external connectivity. If we look at my resolve.conf on this system, I have a name server set up to the Google DNS, and we're just going to do a ping out to 8.8.8, and we can see that external connectivity is working from the fabric. But what does that look like for the entire path of the fabric? So we'll go back, we'll turn on our packet captures. We're not getting it there. All right, so we can see on Ethernet 1.1, the packet capture is coming back. We're getting a response back. If we trace this out, because we're going through spine 1, we can look at spine 3 or E313 spine 1, and we can check the packets there. We can see the response and reply for my ICMP is coming back. Now let's look at the border gateway. When we come over here and we do the packet capture, and actually just real quick, we'll stop that. You can see we're still VXLAN here, so the ICMP is still going through the VXLAN for VNI 10101, same as we saw here. When we look at this interface, we should see the packets coming through. We see the ICMP. We can see we've returned back to just a standard Ethernet packet. The difference here is that on the external connection out from the switch to the router, I have 802.1q tags set up so that I can provide sub-interfaces off the router, and we can see that I have this virtual LAN configured. We can see that it's 101, which is where the association happens at the switch to put it back in just a traditional VLAN to get to the router. If we go look at the interface heading out to our NAT connection, we can look at the packet capture, and we see the packet capture is headed out. We can see the source is to the NAT address that's configured on that external connector, and we can see the response back. Now, if we go back and we stop this, and let's find the external router, if I do show IP NAT translations, we'll see that we have a inside global to inside local. So this is the NAT connection for the inside heading out to the outside. So I'm NATing to my address that's assigned through CML through the NAT connector with this IP address that's part of the VXLAN Fabric, and I'm heading out to the 8.8.8 server. Now, it's ICMP. I don't always like to use ICMP as my test. What if I do, see if I can do this right the first time. Let's do apt or apk add Python 3. So we can see it's able to reach out to the internet to pull stuff in. And if we go back and we look at, get this out of the way, the external router, we should see a bunch of connections now. We see some UDP for DNS. We see TCP to get out to the PyPI servers, or actually the servers for Alpine to pull in its software. And we can see the ping is still running from a different host. That is now gone. If we go back to our system, it's installed the package. And we should see that translation die off in a second. If we go back here, we've installed Python. Let's do one more, sudo apt install or apt add py3.pip. So now we're going to pull in the Python package, go look, we should see some translations again. And again, we see the translations out to the server. If I had been monitoring the packet capture, we would have seen these packets go out through VXLAN. So since I didn't do that, let's try an SSH session from server A to 172.102.1.101. And before I do that, what are we connecting to? I'm saying from server A, I want to route through the fabric over VNI 101.101. And because that's not part of the VXLAN Fabric, I don't have L2VNI set up here. We're only doing L2. I have to go all the way to the border gateway here, to this external router, and my gateway sitting there. That will route me back to the 102 address. So let's watch this packet capture. I'm going to clear this. Let me close these out real fast. Just clean this up a little bit. All right, so we've got this interface. We're going to watch this interface. And we're going to watch this interface. So what are we watching? We're watching the link. Actually, we're going to add one more here just in case it gets put on a different link. So we're watching the two uplinks to the spines from leaf 1. We're watching the connection from the external router to the border gateway. And then we're looking at the interface connecting to server B. And actually, we don't want to do that, do we? No, we want server D, so we're going to do 50.3.101. Let me close this. Packet capture. All right. Come back. We're going to start all these up. I'm going to bring my terminal back up, and we're going to go to 50.3.101. We can see the SSH happens. I'm going to log in as Cisco because that's the default username. And we see we're on server D. We went through the fabric. I should be able to come back here and we should be able to look at the packet capture. And we should see our SSH session coming to that host. Page 2, 3, did not show up here. Let's check this guy. Oh, that's right, because it's the interface right here. So we should see here our there we go. There's our SSH connection. So this is just a normal frame. This interface is connected to the switch, so we don't see the VXLAN header in there. We don't need this one up. Let's look at this guy. We can see. No, yeah, there we go. We can see the SSH session. So we can see. If we close this, let's click on the actual TCP session. All right, TCP. There we go. Minimize all this. So we can see our TCP packet. We're doing a source of 22 from a destination of 43.192. This was the packet coming back from 50.3 for that session to the server A host. We can see the IP. We can see the original frame that has been encapsulated in VXLAN in VNI 101.101. We can see the VXLAN portion of this frame where we went from a source of 214. So this VTEP 214 right here sent a frame back to 212. And basically what we're seeing is this server sent its packet back, so it either went this way or this way, came back to the border gateway, hit the router, sent the packet to the border gateway again because we had to route from 50.3 to the external router over to the 101.254 to go back into the border gateway to get back to 101. We hit the border gateway. That's our source. Our destination is back to leaf 1. We send the packet over, and then we reach server A. And we should see a similar thing if we find a session back. We see that the VTEP1 host sent to a destination of 214. Again, the VXLAN encapsulation of the packet. This was the response back to the SSH server. So we can see this path, this packet trace basically of how a packet from the host on leaf 1 reaches to the border gateway, heads out to its external connection, comes back in, reaches its host, and we get, even though we don't have the external connectivity baked into, or we don't have the L3 connectivity baked right into the VXLAN Fabric, we're able to use this external router to send traffic in and out of the fabric between hosts. For a small fabric, this is okay. You know, it's not a lot of load on the host. As you get into more complex fabrics, as you start wanting to build some multi-tenancy between your fabric or between your VNIs and your fabric, it may be more desirable to have the routing occur within the fabric. And that's one of the things we're going to cover in the next part of this series for VXLAN EVPN, and that's L2VNIs. With the L2VNI, we still need external routers for connectivity out to the internet, but we can build some routing between, let's just say, these two guys right here, or these two right here, without even leaving the fabric. We won't need this router for that purpose. We can use an L2VNI with a VRF to say, VNI 101, 01, 10102, and 10503 are all part of the same L3 VRF. We should be able to route between them, and that routing will happen without leaving the fabric. So the last thing I want to show real quick, because I don't think I showed it yet, let's look at the leaf switch. Here we go, console. Yeah, leaf. Let's look at show run, and let's look at interface E1/3 and 4. Now, if we look at these interfaces here, they just look like your standard everyday access port. There's nothing special going on. When we do show run, let's just do VLAN. We see the VLAN configuration here of 101 and 102. When we look at the individual VLAN configuration, that's where the segment for VXLAN is defined. So as far as the switch is concerned and the access port is concerned, it's just a VLAN interface. There's nothing special going on there. If you know how to configure VLANs on a switch port, it's no different when you do it in VXLAN. The VXLAN portion only comes into play when you need to go from leaf 1 to leaf 2 or that border gateway in this design so that you can reach another host in another VTEP. And like I said earlier, you see that we only have the segments defined that are on this host. That's pretty much status quo. Like you should always only configure the host that you need. You wouldn't configure 100 VLANs on a host that didn't need all 100 VLANs. You'd prune them off. In this case, we're just not configuring the VNIs that don't belong on the switch. So this guy doesn't have 503. The leaf 2 switch doesn't have 102 assigned to it, but the border gateway switch, which does need all 3 VNIs, has all 3 configured. And that's pretty much the equivalent of pruning off VNIs in a VXLAN Fabric. So I hope this was really helpful for you guys. Let me know what you think in the comments. I'm really looking forward to your feedback. I know everybody seems really interested in this topic. I know the video is pretty long, but there's a lot to show in this configuration. But now that we've done this, we can do a much shorter video that focuses on the L2VNIs when I do the next set of the series. So let me know what you think. Thanks for watching.